In this video, we'll review how to graph sine and cosine functions with phase shifts. Phase shifts are horizontal shifts. Now recall from our work with the Ferris wheel that we use sine to measure the rider's height as he or she turns around the ride. Typically we start on the extreme right-hand side, or the standard position, and rotate in a positive, counterclockwise direction. This means the rider's height starts at the Ferris wheel center height, and then increases until they get to the top, which is their max value, goes to center, min, center. But what if we started the rider's time at a different position? What if we started the time when the rider was at the top? We would still use sine to measure the rider's height, but the rider, instead of starting at center, would be starting at their maximum height. They would go from maximum to center to min to center and max. This is a phase shift. We're starting the graph at a different position. If we started the rider's height on the right-hand side of the Ferris wheel, the graph would look like this. It would go from center to max to center to min to center. Again, from center to max to center to min to center, if we started the position on the right-hand side, when they're at the center height. But what if we started the rider's time at a different position? What if we started the time when they were at the top? The graph would look like this. Now this may look like a cosine graph, but it's really sine graph started at a different place. We started the clock late. We started the time when they were at their maximum position. Their center happened previously. It was here. And then when we started the clock, they were at their max, and then went to center, min, center. It's really a sine graph, just shifted to the side. This is a phase shift. Any sine graph can look like a cosine, a negative cosine, or a negative sine by simply shifting the graph side to side. The same is true with cosine graphs. The parent function of sine is this. F of x equals a sine, quantity, b quantity, x minus h, plus k, where a is the amplitude, b is the frequency, h is the horizontal shift, and k is the vertical shift. hk are sometimes used with other letters. Sometimes you might see them written with c's and d's. However, I'm going to use h and k's because I've used it with every other transformation we've ever done with any type of parent function. H being the horizontal or phase shift, and k being the vertical shift. Now you need to be careful when determining the horizontal or phase shift, especially when the frequency or b value does not equal 1. If the b is not equal to 1, then you need to either write this equation in this form, and there's two ways to do it. So if it's not in this form, you can either factor the piece that's in the parentheses, we call that the argument, to put it in this form, or you can set the argument, the piece in the parentheses, equal to 0, and solve for the phase shift. Either method will work. Now, if b is 1, you can just look at it, and it's going to tell you the x minus h value. Just remember, h is the opposite. So let's look at some examples and try to find the phase shift for each equation, or each function. In the first one, f of x equals 3 sine quantity x minus pi over 2 plus 3, the b value is 1, which means we can look at this problem and we can see the phase shift. It should be x minus h, which it is, which tells me that the h value is going to be pi over 2. Now I can still set the argument equal to 0 and solve it this way. If I take x minus pi over 2 and set it equal to 0, I can then add pi over 2 to both sides, and I get x equals pi over 2. This matches what I saw above. The h value, or the phase shift, is pi over 2. This graph starts pi over 2 to the right. Now the other three problems up here, the b values are not 1. So these are going to be a little bit trickier to find. We either need to factor the argument, the piece in the parentheses, and then look at x minus h, or we take the argument, the piece in the parentheses, set it equal to 0, and solve for x. So I'm going to show you both methods here. For problem number 2, I'm going to take the 3x minus pi, I'm going to factor it out. It's got a 3 for the frequency, so I'm going to factor a 3 out of both the 3x and the negative pi. 3 goes into 3x 1x times, and negative pi divided by 3 would be negative pi over 3. This means the new function would be f of x equals negative 4 cosine, the quantity 3 cosine, parentheses, x minus pi over 3, and then plus 7. So it'll look like this. I factored out the 3. Now I can see the shift. X minus h tells me that the h value is pi over 3. Now this may seem a little tricky, and it gets easier over time, but it is the quickest way to do it. The other method, setting the argument equal to 0, is probably easier, but it's going to take a little longer. So let's look at that method. We take the 3x minus pi and set it equal to 0. We add pi to both sides, and then divide both sides by 3. X equals pi over 3, and that matches what we saw above. The h value is pi over 3. Why don't you go and try the numbers 3 and 4, pause the video, work them out, and then when you're ready, resume the video and check your answers. I'll give you a moment to do that. All right, hopefully you had a chance to do this. So if I factor in the next problem, I'm going to get f of x equals 2 cosine, and then factoring. X over 2 is really the same as 1/2 of x, so I'm going to have to divide by half. Half divided by half is 1, so I get a 1x. And then pi over 2 divided by half is just going to be pi. So I get f of x equals 2 cosine, quantity 1/2, quantity, x plus pi, and then plus 5. This tells me that it should be x minus, it's not. So in this case, the h value is negative, and h is going to be negative pi. Now if instead I set it equal to 0, here I got x over 2 plus pi over 2 equals 0. I'd start by moving the pi over 2 to the other side. So if I subtract pi over 2 from both sides, I get x over 2 equals negative pi over 2. I can then multiply both sides by 2 to isolate x, in which case I get x equals negative pi. And this matches what I saw above. The horizontal or phase shift is negative pi. On number 4, I'm going to have to factor out a 2. So I would get f of x equals negative 7 sine, quantity, 2 quantity, and then divide. 2 goes into 2 once, and pi over 4 divided by 2 is pi over 8. So it's going to look like this. The h value should be x minus, it's not. This tells me h is negative, and the h value is going to be negative pi over 8. Now if I set it equal to 0, so the argument 2x plus pi over 4 equals to 0, subtract pi over 4 from both sides, and then instead of dividing by 2, I'd probably multiply by 1/2, because I don't like dividing fractions. So if I multiply by 1/2, I get x equals negative pi over 4 times 1/2. Well, negative pi times 1 up top would be negative pi, and 4 times 2 on the denominators would be 8. I would get negative pi over 8. And it's the same answer again. Either method works. Pick whatever one you think is easier and go with it. Now let's look at some graphing with phase shifts. Here's the first one we're going to graph. We have the function f of x equals 5 sine, quantity, 3x minus pi over 2. Now this one I can't just look at it to see the phase shift. I can see the amplitude is 5, I can see the frequency is 3, and there's no vertical shift. The period would be 2 pi over 3, if we do it in radians. But the phase shift is trickier. It's not a 1x, it's a 3x, so the frequency being 3 tells me that I'm going to have to factor the 3 out, and then rewrite it, or set the argument equal to 0, and solve for the phase shift. Now if I try the factoring, or if I saw the, let's try the solving technique first. If I set the argument 3x minus pi over 2 equals to 0, I can start by adding pi over 2 to both sides, and I get 3x equals pi over 2. I can then multiply both sides by 1/3, and I get the horizontal or phase shift being x equals pi over 6. Now if we try the factoring form, it's going to look like this. 3 divides into 3x 1x times, and 3 divides into negative pi over 2, negative pi over 6 times. And I can see that x minus h value being pi over 6. Both methods work. Now because we're shifting to the right, we're going to pi over 6, it means I don't need much room on the left. So when I graph, I'm going to make my vertical axis on the extreme left-hand side. To scale the graph, I see that the period is going to be 2 pi over 3. That means the full cycle, or my fourth tick, is going to be my 2 pi over 3 mark. Half of 2 pi over 3 is pi over 3. That would be the half cycle. And then half of pi over 3 would be pi over 6. That's going to be the quarter cycle, or the first tick. So counting by pi over 6, for each tick mark, 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 3 is the 2 pi over 3, the full cycle, and so on. Now this sine graph is going to be shifted. We're going to start the sine graph at pi over 6. So if I start my center at pi over 6, I'm going to put a dot there or a point. This becomes my new starting point. A phase shift is just simply a new starting point for your sine or cosine graphs. Now the amplitude is 5, which means when I go from here to my maximum, I'm going to be up 5. So at pi over 3, I'm going to be up 5. And then it's going to do what all sines do. It goes from center to max to center to min to center. There's one complete cycle, just shifted pi over 6 to the right. Now repeating the cycle, I would go at pi to max, to center, to min, and I've run out of room. Now I can simply add another point to the right, or I can work backwards and finish the graph to the left. If I look at where I was at pi over 3, which is max, pi over 6 was center, that means when x is 0, I'd be at the minimum value. This ends up looking like a negative cosine graph. but it's simply the sine graph shifted pi over 6 or 1/4 cycle to the right. And then we'll sketch the graph. Now keep in mind, sometimes in my class, people ask me, well, why did you graph a negative cosine? I didn't. I graphed the sine that's been shifted, and when you shift a sine graph, it can look like any type of positive or negative sine, or even positive or negative cosines, depending on how much you shift it. So let's try another example now. Here we have f of x equals -3 cosine quantity 2x plus pi. I can look at the graph and easily see that the amplitude is 3, the frequency is 2, there's no vertical shift, and the period is going to be 2 pi over 2, which is going to be pi. But the horizontal or phase shift is going to be a little bit trickier. Again, because the frequency is 2, I can't just look at it. It's not going to be negative pi. Instead, I either set the argument equal to 0 and solve for the phase shift, or I can factor out the 2 from inside that argument. Either method will work. So if we use the solving technique, we're going to set 2x plus pi equal to 0, subtract pi from both sides, and then divide by 2. We get that the horizontal or phase shift will be negative pi over 2. This means I'm going to need room on the left-hand side of the graph in order to be able to complete it. If we try the factoring technique, it would look like this. And I can see that it should be x minus. It's not, which is why I know that the horizontal or phase shift has to be negative pi over 2. Now when I go and set this graph up, again, I need room on the left-hand side because I'm shifting it to the left as a starting point. Now how many ticks or how many parts of the cycle, I got to look at the graph a little bit more to see that. The period is pi, which means the fourth tick is going to be pi. If the fourth tick or full cycle is pi, then a half cycle would be half of that would be pi over 2. This means because my shift is negative pi over 2, I'm going to need 2 ticks to the left. So when I set my horizontal shift up, negative pi over 2 is going to be 2 ticks to the left, and that's where I'm going to start my graph. So here I have my axes all scaled out. Again, the way I thought about this, the period being pi tells me 4 ticks is going to be pi. 2 ticks, half of that would be pi over 2, which means 2 ticks to the left of center, a half cycle to the left of center, is going to be negative pi over 2 in this case. And that is where I'm going to start my negative cosine graph. Negative cosine graphs start at the minimum, but in this case the minimum has been shifted negative pi over 2 to the left. That would be this point right here. It's a negative cosines. Negative cosines go from minimum, which I have, now to the center, to the maximum, to the center, and then to the minimum. That would be one complete cycle of this negative cosine graph shifted pi over 2 to the left. Now I'm going to repeat the cycle. If I'm at the minimum, the next point would be the center, the max, the center, and the min. If I go from negative pi over 2 to positive 3 pi over 2 in this case, I've gone 2 complete cycles. I've gone from minimum to minimum to minimum one more time. And here's the graph. Thank you for watching this video, and hopefully it helped you understand how to graph phase shifts.